Hello.
Hello.
I'm Dr Sergis from Dr Sergis Academy, and what we're doing here is illustrating how energy is passed on as a wave. Now, if you look at this, this is the waveform generated by vibration from the frequency generator here. That is sodium. Okay. Right. Sorry. Yeah. All right. So hope you enjoyed that. I'm going to show you how battery works now.
We are at the Dr Sergis Academy here. They have their opening day today, and we have the chance. We like to speak to Dr Sergis, and I think it's a good idea to go back, and just make a journey back and find out who is Dr Sergis. All right, you're born in Nicosia, and you were coming here when you were...
I was 18 months old, yes. Okay. I'm Dr. Andrew Sergis, or Andreas Sergis, or Andros, as my father used to call me. Sergis. I was born in Lefkosia. I was 18 months old when my parents decided to come to this country. And I've always been inspired by science and maths. I mean, I was always curious when I was quite young. As a little boy, my parents didn't have much money, working class background, but they gave me a couple of old encyclopedias, incomplete, maybe 2 or 3. All I was interested in was looking at the section on Jupiter, Neptune, and all the other planets, and I was really curious about what they were made of and everything. And also my primary school, I was looking at trying to understand whales and dolphins and all the other different animals. So I was always curious early on as a little boy. And you know, I it was implicit from my parents that education is important, and I was also inspired by the classical Greeks, and then the classical Greeks gave us everything. Unfortunately, they were self-destructive. They destroyed themselves, but they gave us everything. They gave us what we call the Western values, although whether we hold them or not. They gave us that philosophical view of democracy, science, knowledge, and moral ethics, even religion, unwittingly, although they were not, they were not Christian or Islam or anything, but they unwittingly gave us that because later on, religious people after that, they used their philosophy to make the New Testament and the Quran and everything. So, unwittingly, they formed the ethical basis of religion. And they were great scientists and thinkers. They were curious. They were curious. They decided to move away from believing different gods. And what they saw, and one beautiful word they came up with, is phenomenon. Mm-hmm. Natural events, and they tried to understand that. That inspired me, and I worked as a lecturer at University of Greenwich, and I got my doctorate. I've got professor qualifications. My doctorate is in science, and I lectured at University of Greenwich, the chemistry department. Then I lectured at University of Westminster. Then I was a senior research officer at Hammersmith Hospital making anti-cancer drugs in South London. And when I moved to North London, I taught in a variety of schools. I was a governor for 11 years. And because I improved the three major schools, improved their curriculum, their science, maths and English curriculum, I was awarded a medal by the Mayor of Enfield some years back. And then eventually I decided, after teaching a lot of schools and helping them achieve grade A's, I decided to open my own school, the Dr Sergis Academy, because it actually uses the specific methods which I find effective to teach students how to think. And teaching students how to think is what education is. And what do I mean by how to think? In other words, how to see and analyze every single sentence and how it's backed up by evidence rather than hearsay, rather than accept what people say, memorize this, memorize that, parrot fashion, which unfortunately happens in schools and in tuition centers, just memorize this. That is not education. Education is when you question things. Yeah. An educated person questions everything, try to see evidence behind it. And this is very important. This is what I achieve. And a lot of my students get grade A's. Okay, and I do my best at the Dr Sergis Academy, where I teach. We have a university laboratory where we do experiments, because it's important that we actually back up the theoretical side of science with empirical research experiments. And the word empirical is an old Greek word. It means experimental. So we try to make sure that we teach students how to think logically, how to come up with the proofs, and how the theory in science evolves from doing experimental observation evidence, and also mathematics, which is the language of science. Mm-hmm. Mathematics is the only language of science which is the language of logic, and how we use that to formulate scientific theory, how we use mathematics. So I can teach primary school students, I teach little ones as well, but mainly secondary school students from ages 11 right up to 18, and teenagers and adults. And I teach GCSE, A-level and degree level in science, that's chemistry, physics, biology, mathematics, and English. So the science and maths is up to and beyond A-level, so I teach degree level as well. Okay, and it's a very popular school that we have at the Dr Sergis Academy. We're near Enfield Town Station off Southbury Road. That's 52E Southbury Road, EN1 1YB. And do come and visit our centre, and it'll be a pleasure to show you around the academy. Like I said, a lot of my students achieve grade A's, and we are highly recommended by a lot of headmasters and headmistresses.
Okay. A short question, long answer, but
yeah, that's right.
You answered me nearly all my questions. Now, when did you open exactly? How long have you been running the academy? Right.
My teaching career goes back from 1986, my teaching career.
Talking about the academy.
But the academy itself, here, I opened it back in 2012.
Okay.
2012. And it was up and running at 2013, because I had to have it all basically made it conducive for learning and had to actually design the lab and everything in the classroom. So that took about a year. So we're looking at 2012 and 2013, it was up and running.
Okay. Who are your students? I mean, are they students coming here to, they're especially, students, they have, they come from various, ages and schools or what?
We have a cosmopolitan cohort of students. They come from, we've got Polish students, we've got Greek students, we've got Cypriot students, we've got Turkish students, we've got a whole range of students, and all different abilities. They come because they want to try and understand what they're learning, because at school all they do is just give them handouts. They give them handouts and worksheets, but they don't bother to actually teach them and go through the actual meanings of what they're learning. They just, at the best of times, they memorize things parrot fashion. There's no interest in that. They lose interest, and of course the bad behavior at school doesn't help either. So they come to me because they're not learning enough at school.
Okay, so I mean I can understand what you mean by that, because you say in a school or anywhere else, they just give them papers and they do the exams and all this kind of thing. But here, you analyze the words. You analyze their study.
That's right. I analyze it and I go through the logic by using deductive reasoning. I do a question-answer analysis. I use a Socratic method of question-answer analysis to make sure I have evidence that the student has understood from the first sentence. So I go through a Socratic question-answer analysis to make sure they've understood everything, rather than school where they don't even allow the students to question anything. Even at the end of the lesson, no questioning, and then move on to the next class. Okay. Here, I make sure that I answer their questions, and if they're shy, I make sure I encourage them to ask questions to make sure they understood the lesson before they leave by using reasoning.
Okay, so today it was your opening day.
Yes.
Tell us what's happened exactly. I mean, from the time when you opened to up to now.
Yes, today we have an open day. We have annual open days. Sometimes we have one open day per year or two open days per year. And this is a major event where we basically encourage new students to see our premises. So it's an opportunity for them to see our laboratory and everything and what we do here at the Academy. And we've done quite a few experiments in the itinerary. We've had how a battery works, the reaction of chemical elements, the reaction of metals, how, for example, wave works. So a wave is a very useful way in which energy is transferred, and everything in terms of trying to understand how science works in order to encourage them. Because at school they don't do enough experiments.
Okay. Tell us about, how can anyone enroll, and are the times various? What times are the lessons, and are they weekends, evenings? When are they?
Yes, so you can enroll at the Academy by actually looking at our website, and if you type the Dr Sergis Academy on our website, we've got our number. My number is, you can ring us on 07951 579 245. So that's 07951 579 245. That's the Dr Sergis Academy, and then we'll book you in for a diagnostic. What we say in the trade, a diagnostic, meaning we actually show you around for a few minutes, might be 15 minutes or 20 or 25 minutes, and I can explain my methods. So there's no obligation. So the first introduction is just to show you around the Academy, and I would explain to the parents how I teach, and everything that to address all their questions.
Lovely. So what is your message to the parents, first of all, and then to the kids, the students? Why do they have to come here?
Right. Now, here they're actually learning 100%, because in order to perform well and to excel in the subject that you're studying, it is important to understand it thoroughly rather than simply to memorize it. Because at school they give you these Mickey Mouse diagrams and say, put your finger there, etc., do that. That's just completely disgraceful, because that is an insult to the student's intelligence. I'll go through the reasoning behind it in order to understand how to come up with a formula without memorizing things. For example, I could give you a formula for writing down how many dozen in something, given a dozen is 12. I could say if I've got 48 pens, how many dozen on the basis that 12 is a dozen, you divide 48 by 12 and there's 4 dozen, right? But you don't need a formula, it's logic, because every 12 is 1 dozen, how many lots of 12? So I do the same thing with, the logic comes from the brain. Yeah, mathematics comes from the brain. You don't have to memorize things, you can derive them. And this is why they're learning rather than memorize things, because it's very difficult to when you forget the actual memory, the memory aid. If you get the memory aid they give you at school, then you're lost. But if you can derive it from first principles, from logic, then you're never going to be lost. And this is why I encourage them to come here, because they actually properly learn. Because if you properly learn, then you don't have to memorize things, and you can gain a love and inspiration for the subject, and you can study it further. Because if you don't understand something, then you lose interest, and this is what happened at school, unfortunately.
Lovely. Thank you very much, and wish you all the best.
Thank you very much, Vasily. It's a real pleasure. Thank you. That friction generator generates a vibration, and what we have is that's 1/2 waves. So every time that's a node and an antinode, which is high energy, and then you've got 0 energy there. So you've got half a wave there, and a half a wave, that's 1 wave. And then you've got 1/2 waves there. We can alter the actual wave. Yeah. Okay. And you can see the waveform generated by the oscilloscope. This is called a digital oscilloscope, which is a modified form of the original one, which is a cathode ray oscilloscope, which is otherwise abbreviated to CRO, which illustrates how that energy can also travel as a wave. A wave is a useful way in which nature transfers energy. The one important pattern is that the chemical reactivity, in other words, the extent to which the elements react, they get more reactive down the group. Okay? So lithium is quite reactive. Metal, from the Greek lithos means rock in Greek. Na stands for natrium, which is Latin for salt. K is co-touch, which is Latin for ash. As you go down the group, they get more reactive. So lithium is reactive, sodium reacts violently with substances, potassium even more reactive. So as you one pattern or periodicity is they get more reactive, it means more violent with substances when they actually interact with substances, they get more violent as you go down the group. So potassium is most reactive. You can see that now. We're going to illustrate that with the actual water. Now, so in the water, so we've got a drop of water here. So I'm going to illustrate how the elements react with water. So we're going to start with the least reactive element, which is lithium, right at the top, as you saw earlier. Okay? Because they're very reactive with water, so sweat is made of water, so of course it would actually destroy my skin, and I'm going to have 3-degree burns on my skin if I actually touch these elements. Now they're stored in oil, okay, and normally it's xylene, the oil, or liquid paraffin, because we want to prevent them from reacting with the air, because they react violently with the air and water and indiscriminately with any substance. So we keep them in oil to prevent them from reacting. So we're going to start with the least reactive one right at the top, which is lithium, yeah. So the least reactive one will just skim the surface of the water, will just pop up and down on the water. And so this is lithium. You can see the grey layer, which is lithium oxide, yeah, look, which is grey lithium oxide. Okay, I'm going to have to scrape, because it's lithium oxide, the skin. It will prevent it from reacting with the water. It will stop it from reacting with water. I have to remove the skin. Okay, sorry. Right, you can see the silvery layer of lithium underneath. I've exposed the lithium now because I've removed the actual grey, oxide layer. So I've exposed the pure lithium. I'm going to chuck it in water, I think perhaps I should put the fume cupboard on. Oops, sorry. Yeah, and that's lithium. You can see it's skimming the surface of water, how reactive. It's reacting with water and it's producing a gas known as hydrogen gas. Yeah, so it produces hydrogen. Yeah, hydrogen gas. Hydrogen got its name from the two classical Greek words. Ithro is the classical Greek word for water in Greek. Classical Greek, ithro means water. Genesis means producing in Greek, so it's water making. Because hydrogen reacts with, why is it called water making? Hydrogen, water making, because if you burn hydrogen, it burns with a blue flame, and guess what it makes? Water. That's why it's given the name hydrogen. We're going to chuck in the next element below lithium, which is sodium. Okay, so we're going to chuck the lithium back in, and we're going to use sodium. Sodium is more reactive. Sodium will produce a blue flame. There are exothermic reactions. Exothermic means heat is released. There are exothermic reactions. Sodium will produce. Right, so if we take sodium out. Now, one of the things about sodium, it produces a yellow flame. That indicates that it's sodium. Right, sodium. I'll check in sodium. Right. I'll check in sodium as well. So there we are. The yellow flame indicates that it's sodium. Okay. Right. Oh, sorry. Yeah. Okay. So, are you okay there? Yeah. Shows how reactive it is. So it's all controlled. It's all safe. Yeah. Now, the salt is what powers the electricity. So the electricity comes from the salt, yeah? There we are. Now if you stir it, if I may, okay, so you can see, yeah, just see, if you switch off the light, someone, just see,
Yeah.
just see, the salt contains sodium chloride, so the electricity, the electrical particles get out of the salt, and then pass through the cable, and then through the light bulb, which produces the light. Yeah, so the electrical particles are from the salt. Yeah, and the salt, as the electrical particles come out of the salt contains sodium. The sodium of the salt takes up electrons and it produces hydrogen gas. So there's hydrogen gas coming out on one end, which is the positive end, and the negative end is where chlorine gas is given off because salt has chlorine in it as well. So we're gonna, it's come out again. You see, So the electricity goes from the sodium chloride through through the light bulb, and it lights up. And you've got hydrogen coming out from one end and chlorine gas the other end.
But
we use chlorine gas.
There's so much to learn before that, I suppose.
Yes, well, there's a lot of detail in it. That's right. Yes. But it's basically, that's the general pattern.
I mean, this is the end of the product.
Yes, that's right. Exactly.
It's a big journey.
But it's amazing how
it is amazing.
How it all works, nature, because there is an order in nature. The universe that we exist in, there's an order. The cosmos, the universe that we exist in, there's an order. And the ancients somehow discovered this order, and they saw there's beauty in the order, and they realized the order, because they love mathematics, can only be explained mathematically, because there is mathematical logic. There is an order. It's not chaos. And then there's laws, as they call them. They call them laws. The ancients, and the laws of nature, and we're still trying to understand that.